Okay, today we're going to talk about how to simplify rational expressions. Okay, so remember what is a rational number? A rational number is any number that can be written as a fraction. Okay, if it's an actual number, it's a number that either terminates, the decimal terminates, it ends, or it repeats. All those types of numbers can be written as rational numbers. But today we're talking about rational expressions, so we don't have an exact number. We have an expression with a variable. So we're going to start by simply simplifying. So let's look at an example. What if we want to simplify the rational expression x squared plus 7x plus 10 divided by x squared minus 3x minus 10. Well, anytime you want to simplify anything in math, simplify means to try to get it as small as possible. Try to condense it down, cancel something out in order to end up with something smaller. So if we look at our rational expression here, it is rational because it is a fraction. Notice we have a quadratic expression on the top and a quadratic on the bottom. So anytime we have a quadratic expression, we want to see, can we break that apart into its linear components? So what we've learned so far regarding quadratic expressions is how do I break them down into its linear components? Well, since this is a quadratic trinomial, I'm going to be looking for, are there two numbers that multiply to 10 but add to 7? So if I think about my possible options, what options do I have? That two numbers that multiply to 10 but add to 7? Well, the only options for 10 are 1 and 10 and 2 and 5. How am I going to get positive 7? That's going to be out of a positive 2 and a positive 5. Oops. Okay, well, let's do the same thing with the denominator. I'm looking for two numbers that multiply to negative 10. But, let me fix that. You can't read very well. But add to negative 3. Sorry. Zoom's not working. So two numbers that multiply to negative 10 but add to negative 3. So again, 10, I still have my 1 and 10, 2 and 5. This time we need negative 3. So again, we still have 2 and 5. But to get to negative, that means that my bigger number, 5, needs to be negative. So negative 5 plus 2, yes, that gets me negative 3. So I can factor the denominator as x plus 2 times x minus 1. Numerator is factored as x plus 2 times x plus 5. Well, let's look at that rational expression. And what do we notice? Does anything cancel? If I have a number divided by the same number, well, they will eventually cancel out. So what do we notice on the left-hand side? X plus 2 divided by x plus 2, anything divided by itself is just 1. It doesn't just poof disappear. Okay, it actually simplifies to 1. And if we're just multiplying by 1, we don't really need to write that. So let's see what's left. X plus 5, x minus 5, we can't simplify that, so that's going to be our solution. But with rational expressions, we do have to tack something onto our answer. So when I simplify this original rational, yes, it's going to simplify to x plus 5, x minus 5. But rational numbers are very special. Numbers that are expressions with fractions are special, as in the denominator can never, ever, ever be 0. So what we need to do is we need to look at this denominator. And this denominator can never, ever be 0. So what number is going to make this denominator 0? So denominator can never equal 0. Never equal 0. So that means that x minus 5 cannot equal 0. So if I add 5 to both sides, that means that x cannot equal positive 5. So we have to tack that onto our answer. Yes, this expression simplifies to x plus 5 divided by x minus 5. But because the denominator can never be 0, this we have to tack on that x has a restriction on the domain. X cannot be positive 5. Now, not only can the simplified denominator not be 0, no denominator at any point can be 0. So even this guy here, well, if x plus 2 equals 0, x plus 2 cannot equal 0, which means that x cannot equal negative 2. And why that is, if I plug this into my original denominator, negative 2 squared minus 3 times negative 2 minus 10, I'm going to get division by 0. That's not allowed in math. So we have to restrict that one as well. So because your original rational expression was x squared, that means you should have 2 restrictions on x. So our 2 restrictions on the domain of x is x cannot equal 5, and it also cannot equal negative 2. So this is our full simplified solution. So let's take it up a notch and let's multiply. So let's look at this problem. What if we have 2x minus 8 divided by x squared minus 16 times x squared minus 5x plus 4 divided by x squared plus 8x plus 16. So how are we going to multiply? Multiply and simplify. Well, we should start by always factoring. Always try to break it down into its smaller parts, because if we can break it down, well, then hopefully something will be able to cancel out. So if we look at the first one, 2x minus 8, that has a GCF of 2, so we can factor that as 2. Well, if we pull out the 2, 2 times x will get us 2x, and 2 times negative 4 will get us a negative 8. Now let's look at the bottom denominator, x squared minus 16. Well, x squared minus 16, that is a difference of squares. That is a difference of squares. So difference of squares means that ding, 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 16 is a special kind of number. Square root of 16 is 4. Because we have a difference, a minus in the middle, that means that one sign is going to be positive, one sign is going to be negative. Because when we FOIL this out, you get your x squared. X times negative 4. 4 times x is positive 4. Those cancel. And then 4 times negative 4 is negative 16. So let's try to factor our second rational expression. Again, we're looking, because it's a quadratic trinomial, we're looking for 2 numbers that multiply to the end but add to the middle. So if we have so let's see here. Our numerator is x squared plus 5x plus 4. Can we find 2 numbers that multiply to 4 but add to 5? So options are 1 and 4, 2 and 2. To get 5, we need a positive 1 and a positive 4. Let's look at the denominator. We need 2 numbers that multiply to 16 but add to 8. Multiply to 16 has a couple of options, but to add to 8, we need 4 and 4. So let's see. We broke everything down. Is anything going to cancel? So let's see. If we have something on the top and the bottom, it can cancel. So let's cancel away. We have x plus 4 divided by x plus 4. That cancels. Do we have anything else? Here we have x minus 4, that cancels. And I think that is it. So let's put what we have remaining. Notice here I have a 2 on the top. I also have x plus 1, because remember, how do we multiply fractions? Top times top, bottom times bottom. So I can multiply everything on the top, which all that's remaining is 2 times x plus 1. Let's look at the denominator. What do I have left in the denominator? I have x plus 4 and x plus 4. So we could go on ahead and simplify this out even more and distribute. So this will be 2x plus 2. This will be, if we FOIL the bottom, we're going to get x squared, or you could draw a box if needed. X squared, we're going to get plus 4x, which would be 8x, and then plus 16. So this is our simplified answer, but we cannot forget with rationals, our denominator can never, ever, ever be 0. So we have to look at all of our denominators and exclude any x that would make it go to 0. So x cannot go to 0. So let's look at my denominator. Well, just from this first denominator right here, well, x plus 4 cannot go to 0, therefore x cannot equal negative 4. Negative 4 we're already taken care of, so I don't need to worry about that one. Notice here, even though we canceled it, this x plus 4 cannot equal 0, therefore, we've already taken care of that one, negative 4. Negative 4 is already taken care of here. What about this one? X minus 4 cannot equal 0, therefore x cannot also not equal positive 4. And I think we are good. So multiplying these two rational expressions, we get a simplified expression of 2x plus 2 divided by x squared plus 8x plus 16. But also, we have a restriction on the domain. X cannot equal negative 4 or positive 4 because the denominator can never, ever, ever be 0. Okay, let's take it up another notch. So we've done basic simplifying, we've done multiplying. It is time to divide. So how do we divide? Well, how do we divide any fraction? How do we divide any fraction is we have to multiply by the reciprocal. Multiply by the reciprocal. I.e. the flip. Okay, so let's look at an example of how we can divide rational expressions by looking at an example. Let's say we have 7x plus 14. Divided by x minus 1. And we are going to divide that by 7x squared minus 28 divided by 5x squared minus 5. So again, this is a division problem, dividing of fractions. So how do we divide fractions? How do we divide fractions? We take the first fraction, that stays the same, 7x plus 14 divided by x minus 1. But we're going to multiply, change division into multiplication, by the flip. So if we flip this fraction, we're going to have 5x squared minus 5 over 7x squared minus 28. So again, why did we do this? We did this because division means to multiply and flip. Multiply and flip. So let's see if we can simplify. So let's look at the first fraction here. We got 7x plus 14. Is there a GCF there? The GCF there is indeed 7, right? So 7 times what will get us 14? That is 2. Now let's look at the numerator of the second fraction. We have 5x squared minus 5. What is the GCF there? The GCF there is they share a 5. Let's look at the denominator, 7x squared minus 28. We have a GCF of 7 there. 7 times what will get us 28? That's going to be 4. We're still not done because notice we have some quadratics. So we have a quadratic with 2 terms and we have 1 and 4. Ding, 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 ding. 1 and 4 are special kind of numbers. Those are perfect squares. So we can continue simplifying those. By taking x squared minus 1, that is a difference of squares. That means we have a parenthesis, parenthesis. I need 2 numbers. Actually, the square, because they're a difference of square, that means that we're going to have 1 positive, 1 negative, and square root of 1 is 1. If we look at the denominator, we have parenthesis, parenthesis. Let's do that in red. Square root of 4 is 2. So we have positive and negative. So because now that we have everything broken down into linear components, this is just a multiplication problem, top times top, bottom times bottom, right? So I can, we can see if we can simplify. If I have a number on the top and the bottom, they can cancel. So if we go through here, I got a 7 on the top, 7 on the bottom. I have an x plus 2 on the top, an x plus 2 on the bottom, and x minus 1 on top, and an x minus 1 on bottom. So what are we left with? We're left with 5, parenthesis, x plus 1. All of that divided by x minus 2. And if we want to go on ahead and distribute that out, we will get 5x plus 5 divided by x minus 2. But we're not done because rational numbers, fractions, your denominator can never, ever be 0. So let's check every single denominator and restrict on the domain the values that will make the denominator go to 0. So if we look at our final answer here, x minus 2 cannot equal 0. So what number, if I plug it in, will make it go to 0? That is going to be positive 2. So we got to restrict positive 2. But keep going down the line. Any 0, any denominator cannot equal 0. So let's look at x minus 2. We already have one there. What about what we canceled? X plus 2 cannot equal 0. Therefore, x cannot equal negative 2. Now, 7 is constant. Okay, 7 doesn't have an option of being 0. It is always 7. We don't need to worry about constants. Only variables. Let's look at the x minus 1 that we canceled here. X minus 1 cannot equal 0. What number, if I plug it in for x, will make that go to 0? That is positive 1. So this one we factored, we're good. Now, the most common one missed is your original denominator, okay? So notice way back here in the beginning, way back here, this is the initial denominator, right? This denominator cannot equal 0. Now, people often forget about this one because you do flip that fraction and it becomes a numerator, but still in the original problem, it is a denominator. So this denominator cannot equal 0. So what does that mean? That means that 5x squared minus 5 cannot equal 0. If we solve this for x, okay, that means that 5x squared cannot equal positive 5. That means that x squared cannot equal positive 1, and x cannot equal positive or negative 1. Well, the positive 1 I've already restricted based on a different denominator, but the negative 1 I do not have. So tack that one to the list, and a fully simplified answer will be 5x plus 5 divided by x minus 2, with the restriction that x cannot equal 2, negative 2, 1, and negative 1. So that shows you a dividing rational expressions.